Okay, so once you get logged in, obviously you all should now have an email with your vouchers in it. I think that was communicated earlier by Greg because he hopped on to tell us. And then from here, what's going to happen is that you're going to get into the review mode section. And remember, there are 6 quizzes for the Solutions Architect Associate in the practice exam. So there's 6 sets of 65 questions. Now, you can pick whichever random one you want, but let's say we do review mode set 5, and that's the one we're gonna focus on. Now, once you get in, did I click on that? Is it still thinking? John's got a great content on his website. He could speed his website up just a little bit. Let's take a look at question 1, right? So a company is using IAM to basically manage access to AWS services. The SA of the company created the following policy for Lambda. So what they did is it looks like they've got a policy that has an effect allow. There's a create function, delete function for any resource. And they've got a deny with a create function, delete function for any resource. They've also allowed a denied invoke function, and they've denied tag resource. Now notice that this deny, by the way, is if the source IP is this specific IP address. Otherwise, it doesn't look like this deny is actually going to take effect. Otherwise, it looks like this create and delete function doesn't have any conditions on it, so it's just going to allow it to happen. So which of the following options are going to be allowed by this policy? So that's the question, right? Now, this is going to require you to understand exactly what this policy does. Now, since this is a condition that says only if it's coming from this IP address, we're going to deny these functions, this policy doesn't really apply unless you're coming from that IP address. So this is going to allow you to delete an AWS function. So what would this allow you to do then? So we are allowed to create and delete a function from any space, but we are denied the create function and delete function action if we're coming from this IP address. So it looks like since this IP address doesn't match this IP address, it would indeed be what Sean says, which is basically create an AWS Lambda function using this other IP address. Now, that's going to require you to know that obviously denies trump allows, but because it has a condition on it, this deny only takes effect if you're coming from that specific IP address. You would be required to know that a /32 is this specific IP address. Otherwise, you can do pretty much anything you want as long as it's not this IP address. And so if we look, it'll tell you like this isn't going to work because the source IP is denied by policy. The address is denied by policy. It's denied by policy. Right? Makes sense. All right, let's look at the next one. You've got an on-demand EC2 instance, and it's launched into a VP subnet with the network ACL configured to allow all inbound traffic and deny all outbound traffic. The instance security group has an inbound rule to allow SSH from any IP address, but obviously does not have any outbound rules. So in this scenario, what are the changes needed to allow SSH connections to the instance? Now, the answers here say both the outbound security group and the outbound network ACL need to be modified to allow outbound traffic. But we talked about this. One of the two firewalls only needs one rule to initiate a request and allow the response. One of the network firewalls, right, needs to have a rule, like 2 rules. One to allow the outbound, the request, and one to allow the inbound, the response, right? So which one of these actually requires you to modify this system, or does it even require modification? Well, let's think about this for a second. Let me draw this out. Let's say that this is our network ACL. This is the perimeter of our subnet. And inside of that, we've got a little security group wrapped around some kind of instance. Now, right now, if I put an instance in this thing, like say this is a little server, and let's say that we're going to use blue, right, to show where there are holes in the firewall. So right now, I've got a rule in the security group that says, you know what, I'm going to allow inbound connections into the firewall. But the network ACL is configured to allow traffic. So this is going to work. And by the way, I don't need another rule for security group, right? Because the security group is going to allow that traffic to go out. But for the network ACL, I actually have to have a rule. And right now that rule says that traffic's going to get denied. So I actually need to add a rule that says that this traffic is going to be allowed, correct? Which I think some of you picked up on, which the network ACLs needs to be modified to basically allow outbound traffic. Remember, network ACLs require two rules, one for the request and one for the response. Security groups don't need that. Did that not make sense to anybody? Okay. And by the way, it says here, you only need one inbound rule for SSH, but you need two rules for SSH traffic on the network ACL. Good. All right. SA is working for a fast-growing startup that just started operations in the past 3 months. They currently have an on-premise Active Directory and 10 computers. To save costs in procuring physical workstations, they decided to deploy virtual desktops for their new employees in a VPC and AWS. The new cloud infrastructure should leverage existing security controls, but should still be able to communicate with their on-premise network. Which set of AWS services will the architect use to meet these requirements? So here are the requirements. 1, you have to have virtual desktops. 2, you have to have connection back to the corporate network. 3, they want to use their existing security controls, which means they want to use Active Directory. Which 3 services will give them Active Directory, a connection back to their on-premise network, and will give them virtual desktops? By the way, there's only one of these answers that actually contains the virtual desktop service. So that alone. So one thing that Amazon does, and this is a strategy, is they will give you answers that look remarkably similar on purpose, and then they'll draw distinctions, right? And they'll force you to isolate against what you know of the services, because only one of these 4 answers is right, obviously. And the answer in this particular case is going to be workspaces, because that's the virtual desktop service. We do not talk about workspaces at all inside the architecting class. They just expect you to know what that service does. So that's why we take the practice exams. That's an old drawing, actually. Interesting. Oh, interesting. Yeah, that is an old drawing. Huh. Anyway, so there's nothing really like significant there, right? This is the only answer because of Amazon Workspaces. All right. This is an HPC question. So companies planning to launch an HPC cluster in AWS that does CFD simulations, computational fluid dynamics. The solution should scale out their simulation jobs to experiment with more tunable parameters for faster and more accurate results. The cluster is composed of Windows servers hosted on a T3A medium EC2 instances, As the SA, you want to make sure the architecture provides higher bandwidth and higher packet per second performance and lower like inter-instance latencies, right? Now they're on T3A mediums, right? The backplane on a T3A medium, so this is like super detailed, right? So here's the funny thing, is that they're basically saying, hey, you can either add enhanced network adapter, you can add an enhanced fabric adapter. You can actually deploy parallel cluster to deploy it to manage the APC cluster, or you can do the virtual function interface on Windows instances. Now, that's a lot of really like deep level detail here. So first and foremost, I'm going to say it's definitely not this one because we're not doing virtual functions. So we're going to take that one off. Well, that's actually not a good idea. So I'm just going to take that one off. I don't think that the T3A mediums support elastic fabric adapters because I don't think that they even have the capability. I think they're capped at 5 gigabits per second. So I don't even think that they can run at the systems. I don't think can support the 400 megabits per second for EFA. I actually don't think that they'll actually support the ENA options either. I don't think that's actually possible. I think T3A instances are capped at either 5 or 10 gigabits per second, but I could be misremembering, right? So just through process of elimination, I'm sitting here thinking, you know, maybe it is parallel cluster, but I thought parallel cluster was a framework. I didn't think that you could actually use that to create an HPC cluster, but you know, maybe I'm wrong. So let's just take a swag here and see, because maybe it is the first one. Haha, it is actually the first one. So in this case, by the way, you just have to know that the T3A mediums actually can support an ENA because they can support an ENI. So you can't actually get them to enhance because they're ARM-based, AMD-based systems. But parallel cluster is not going to work because it's actually just a framework. And if we go look at the wrong answers here, for example, parallel cluster is just an open source cluster management tool. It's like a framework for creating clusters. It is not going to provide like higher bandwidth or any kind of enhancements to the system. It's just not going to do that, right? It's just a way of deploying a framework for deploying clusters. Now, here's the funky thing though. If we look at the ENA option, right, it does support up to 100 gigabits. So, you know, even though the backplane of the system isn't going to support a 5 gigabit, you know, more than a 5 or 10 gigabit option, adding an ENA will actually bump that up. Now, the fabric adapter is an ENA with added capabilities, right? But this is not supported on a Windows instance. So it really actually doesn't have anything to do with the like bandwidth capabilities. It has everything to do with the OS bypass capabilities, which Linux can do, Windows cannot, doesn't support it, right? So it's going to function set as an ENA without the capabilities. This one, by the way, the virtual function interface, this is actually a function of not being supported by the actual size of the box. Where does that say this? Doesn't, yeah, it doesn't support the actual T3 medium type. So this is a lot of low level detail. And so notice that you're, in this case, you're probably just gonna have to go through and just like eliminate. Like you're gonna have to eliminate the systems in question. But you would have to know, one, what this supports, right? In order to get that correct. So there are going to be questions like this where it's going to be really hard to answer. So don't expect that you're going to know every single nickel and dime piece, because unless you're doing high performance computing and you're working with ENAs and EFAs, you won't know the answer to this. Okay. All right, next. Data analytics company has a massive volume of data. They store it on their on-premise servers. To scale their systems, they're looking for a cloud-backed storage volumes they can mount using iSCSI from their on-premise application servers. They also have an on-site analytics that frequently accesses local data subsets locally, while the older data sets are rarely accessed. You are required to minimize the need to scale that on-premise storage infrastructure while still providing low latency access to recent data. So which type of the storage gateway services will you meet to do the above requirements? So here's a word of caution. Notice that we have two similar answers here, most likely the answer is going to be one of those two answers. So even if you didn't know, when you see it giving you two similar answers, most likely the answer is there. We know it's not a tape gateway because that's not going to give like fast access. We know it's not a file gateway because that doesn't support iSCSI. So then we're left with the two options, which is we know it's a volume gateway because that does actually support volumes in an iSCSI setup. But is it in stored mode or is it in a cached mode? What's the difference? That's the question. Now, a volume gateway in a stored mode, right, is going to store everything on premise, and it's going to put a backup into S3. In cached mode, it's going to put everything into S3, and only the most recently accessed items are going to be cached at the front of the storage gateway volume on premise. So cached mode uses the least amount of space, but the only things that are going to be fast are going to be things that have been recently accessed. Stored mode is going to make everything fast, but that means you're going to have a lot of storage to make this work. So they're looking for a cloud-backed storage volumes that basically accesses the local data subsets locally, while the older data sets are going to be rarely accessed. That's perfect because both of these are low latency. But one of these takes a lot of storage space and the other one does not. And so that this solves the problem to scale their storage systems. Because otherwise, if you keep it in stored mode, you're not scaling their storage systems. Let's check that out because I could be making it all up, right? So you got to remember this is that, and this is probably the only other distinction you need to know about volume gateway, is that cached mode only keeps recent items off the cloud and puts a copy up onto the on-premise data center. In stored mode, there is a full copy of all data on premise and a full copy of all data kept onto the cloud. Okay. Good. Stored volumes are used if you need low latency to your entire data set. Cool. Clients hosting company website on a cluster of web servers that are behind a publicly facing load balancer. Well done. Client also uses Amazon Route 53 to manage their public DNS. How should the client to configure the DNS zone apex to point to the load balancer? Oh. How in the world are we going to assign DNS to this load balancer? This is an old question, by the way. It's been around for 10 years. Now, I want you to just notice something, by the way. We've got create an A record pointing to the IP address of the load balancer. We've got create a CNAME record pointing to the load balancer DNS name. We've got create an A record alias to the load balancer DNS name. And we've got an alias for a CNAME record to the load balancer DNS name. So you got to know a little bit about DNS, right? Can I put a CNAME? Do I require a CNAME or an A record at the apex of a DNS zone? That's the first question that you have to know the answer to.
CNAME.
Okay, let's go. Let's go with this. Let's go with a CNAME. So someone put their vote in and said CNAME, right? And then the other question is that do I have to use an alias, or can I just have the record itself pointing straight up? Is it an alias? So we put our vote in for CNAME. Is it an alias or is it a direct pointer? So good things to know, right? So let's assume we're going to stick with our CNAME vote, and let's say that it is an alias. Let's just take a guess, right? So the answer is that for an Apex domain name, you actually have to use an A record, but it is an alias, right? So notice in this particular case, create an A record alias to the load balancer's DNS name. So the reason for this, by the way, is that remember that these load balancers are virtual devices. They have multiple IP addresses that scale up and down underneath them. So it's funny when you look at a busy load balancer as it gets busier and you do a reverse lookup on it, you'll see multiple IP addresses start stacking up on that thing as it scales. You wouldn't know that unless you'd actually looked at it, right? So here, what's happening, if you have multiple web servers, it's going to route all the traffic to our website to the load balancer DNS name, right? So it will also support the alias record resource sets, which lets you map tutorialsdojo.com to your load balancer DNS name. So what happens is that Route 53 responds to each request for an alias resource record set with one IP address for the load balancer. So what it does is it returns one of the IP addresses that is currently active for the load balancer, because there could be a bunch of them. But it is an A record, right? So it's an A record because you need to actually have an IP address associated with the apex of the domain. So for example, A record pointing to it is incorrect because you need to be using an alias, because it's going to return any of the IP addresses. So you need an alias for that, since the IP address of the load balancer can change at any time. Creating a CNAME record and a CNAME is not going to use, because CNAME records cannot be created for your zone apex. Not www. But just example.com or amazon.com, right? So you have to create an alias record at the top of the DNS namespace, and you cannot use the CNAME. It has to be an A record, okay? Note that, by the way, you can actually create an alias record for www, right? If you want to go like over to www, if you want to, you can do that as well. That's just something you just have to know. In your brain, if it's not www, like it's not a subdomain, the apex domain, 1, has to be an A record. 2, if you're using Amazon, it has to be an alias. Now, ask me how that works when we start putting static IP addresses on these things. It returns the static IP address. Okay. Question number 7. We're going to go for about 5 more minutes, by the way, because that'll put us right at 30. A company is running a batch job on an EC2 instance inside of a private subnet. The instance gathers input data from an S3 bucket in the same region through a NAT gateway. The company is looking for a solution that will reduce costs without imposing risks on redundancy or availability. So right now, just to draw this out, we're inside of a VPC. And then inside of that, we've got, let's see, it looks like an EC2 instance, and it's on a private subnet. So let's put this thing on a private subnet. Oops, not that. Let's not do that. Got on a private subnet. Let's then go ahead and put our NAT gateway on a public subnet up here. Forster doesn't know how to draw. Okay. And then what happens is that, to make things kind of a little bit more weird, is that somewhere out here across the internet is an S3 endpoint. So we've got like a little S3 interface out here across the public internet that we're, attaching to. So right now, the way traffic is flowing, if I like choose hot pink for that, because that's the right color to choose, it's going out to this NAT gateway, which in turn is going out to the internet, which in turn is going to the public S3 interface, the one available to everybody. So what they're wanting to know is, is there a way for us to reduce costs that without like imposing risk on redundancy or availability, right? So basically what's happening is that it's talking across the internet and it's pulling information in as a result, coming back in. So it's pulling data from this S3 source, right? Now, this isn't necessarily going to cause any charges, any kind of egress charges with S3, because they're in the same region. It does say that, doesn't it? In the same region. They're in the same region. So by the way, what's the cost factor here? What's the cost problem? Which one of these is actually the cost factor? If data transfer charges are not the cost factor, what is the thing that's causing this to cost more money than it needs to? That's right.
Charge for the NAT gateway.
That's exactly right, Sean. That's exactly right, Timothy. Perfect, right? The NAT gateway is not only are you getting charged for all gigabits shoved through it, but it costs 10 cents an hour, right? Now you might not care about that, but you could be shoving petabytes of data through that thing. Petabits. Oh, never mind. Let's just move on. So that's really the problem. So the issue isn't that it's like you're including data transfer. It's this NAT gateway that's the problem. So we could deploy a transit gateway to peer connections between the instance and the S3 bucket. You can't do that with transit gateway, by the way. So that's not going to work. You could reassign the NAT gateway to a lower EC2 instance type. No, that's not going to help anything. Replace the NAT gateway with a NAT instance hosted on a burstable instance type. No, the problem still is that we have a NAT gateway. So the option that we're looking for is really, we need to remove the NAT gateway. And then what you can do is you can actually use a gateway VPC endpoint, which you could actually place just right here. And traffic, instead of going through that other direction, would instead, I'm going to put this actually in a different color. Let's choose dark red. Traffic instead would go from here to here. And technically, it would never go out across the internet. It would go across this private purple interface called a VPC endpoint, and it would never traverse the internet, and you would never have to use the NAT gateway. This is a way of making basically AWS APIs available to private subnets. That's the whole purpose of using either an interface VPC endpoint or a gateway VPC endpoint, is to make these things privately available. Okay. So, by the way, I could be making this all up. Let's just check and see, because maybe I don't even know what I'm talking about, right? Which I don't sometimes, right? But this is the answer. So this would allow traffic to now be private. Okay. Does that not make sense to anybody? Now, if some of you just looked at that, we're going to close it down here. If some of you just went through those questions and you were like, Michael, that was super intimidating. I don't know that I gotten any of those questions correct without your analysis. Good. You're just getting started. If you haven't studied these practice exams and you haven't like seen or studied the material, you should not be prepared for the exam, right? We've only been through 2 days of study. We're going to get the third tomorrow, but even after we're done, like I said, it's only gets you 60 to 80% of the material. That's why the practice exams are here. So tomorrow after lunch, I'm going to walk through all the documentation. I'm going to make sure that every single one of you has the program study guide, has access to Tutorials Dojo, everything like that. None of you are going to get away from this class until I know for certain that you have everything you need to get ready for this exam. And that's what we're going to do before we even finish out the day tomorrow. Okay. And then if we have some extra time, we'll spend some time doing some more practice questions. By the way, I have a video of me just running through these practice questions and doing analysis. If you want that, I'd be more than glad to throw that into your playlist. So for this entire class, just let me know that you want that. That way you can listen to it without having to have the app open. Okay. Good. Okay. So it's 4:37. We're going to end about 25 minutes early. And that's going to be our day today. Tomorrow, we're going to start promptly at 8:30. We're going to run through a couple of different pieces like edge networking and, a couple of other like connectivity pieces. We're going to stop for lunch as normal. We're going to run through some practice exam stuff as I just promised. Then we're going to finish out the day, do some evaluations. And at that point, I'm going to officially close class. You can stay with me and do the capstone lab, or you can go Christmas shopping or whatever you need to do to get ready for the holidays, or solstice shopping, or Kwanzaa, or whatever, Hanukkah. I'm not here to judge. Okay. So I'm going to hang out here, but we are officially done. So feel free to drop when you're ready. I'm going to hang out just one more minute in case somebody has a question. Otherwise, I'll see you bright and early tomorrow at 8:30 a.m.
Have a great evening. Thank you.
Yeah. Have a great evening.
Mike, I will say I've actually gone back and rewatched the videos from the DSO class, the DevOps.
Oh, good.
I mean, it's about, I guess it's been, 18 months now, but I've gone back and rewatched them.
God, has it been 18 months? Man.
Yeah.
I don't even remember last year. So that makes sense to me.
Yeah, exactly. I heard you had a couple of my peers or employees